So are you able to see the screen?
Yes, sir.
Okay, fine. Thank you. Good morning, students. Today we are going to discuss about Sierpinski gasket, a tetrahedron program. So lab program. So today we are going to execute one lab program. So program number 7. So according to your syllabus, we have done 4 resonance line drawing, rotation of a triangle. Next, Cohen-Sutherland algorithm and polygon general scan line fill algorithm. 4 programs we have done. 1, 2, 5 and 9. So we have finished. Now we'll move on to the 5th program, that is program number 7. So design, develop and implement recursively subdivide a tetrahedron to form 3D Sierpinski gasket. The number of recursive steps is to be specified by the user. So I will tell you in simple way. So what actually the program is. So you can observe here there is a term called a tetrahedron and also a triangle. So that gasket means nothing but we are going to generate a triangle. Okay. So we are going to, with the help of 4 vertex point, we are going to construct a triangle in a 3-dimensional space. That is what a 3D Sierpinski gasket. So with that, so usually when you are looking in 2-dimensional view, so we're not able to see all the faces of the object. Okay, so we can able to see some of the faces are part of the object and some of the faces are part is going to be hidden. Okay, but in this case we identify possible faces, that hidden surfaces. Okay, so in 3D space means if you are constructing a triangle faces. Okay, so I will show that what are those and how we are going to create this tetrahedron and how we are going to divide the tetrahedron into some number of other tetrahedrons. Means we are going to divide that by giving the inputs. So we have to provide the inputs. Initially we are going to construct with the default values one tetrahedron. That is the first step. After constructing that tetrahedron, now we have to, the user has to specify the how many times this my tetrahedron has to be divide and again it has to be displayed on the screen, either 1 time or 2 times, 3 times, 4 times, like that n number of times you have to provide the input. So those many times recursively your tetrahedron is going to be subdivide and again you are going to view that on the screen, on the output screen. So means multiple triangles are going to be constructed within the triangle only. Initially you have only one simple triangle. Based on the inputs, those many times your triangle is going to be divided. And then we are going to observe that in a 3-dimensional space. So this is what the problem or the program statement. So we'll look at that. So how it will go. So just are you able to see this diagram? Hello.
Yes,
Yes,
sir.
sir.
Okay, fine. So for you people, it looks like a triangle, right? So you just you think it is in a 3D space. Okay, so just you assume this is at the top. So just if you keep the triangle vertically on the surface, just in a 3-dimensional space, you have to assume. So we can't show in here, but you have to assume. Just you treat this point on the top. Okay, so remaining all this as a base, you can treat like that. So we have different faces for of the triangle. Okay, so with the values and we have the 4 vertices here, A, B, C and D. These are the 4 different vertices we are going to consider. And you can ask on what basis we are going to divide our triangle. So we know that we have four vertices, and we have faces of my triangle, and also on what basis I'm going to identify my, means I'm going to divide my triangle. So that is based on the midpoint. So we are going to calculate midpoint. So based on the midpoint, we are going to divide your triangle. Okay, so that for that that will be calculated by using the equation like a plus b by 2, the normal midpoint. If you suppose, if you give any one line, if anyone asks to find out the midpoint, means how we will do, a is the one vertex and b is the other vertex, a plus b divided by 2. If you do, obviously you will get the midpoint. So same concept only here I'm going to apply for my triangle or tetrahedron. Okay, so just look at this. I have identified some of the vertices with the predefined values. So suppose this is my vertex, and with the values minus 1 comma minus 0.5 comma 0, and with b is with 1 comma minus 0.5 comma 0, and similarly followed by c and d. And I have identified my midpoints here. So like midpoint 0, this is for AB. Similarly midpoint 1 for AC. Okay, similarly for AD midpoint 2, and for B and C mid 3, for BD mid 4, and for CD mid 5. So like this I'm going to identify my midpoint. Later I'm going to join those midpoints so that I will get one more triangle. So now I have initial triangle, and again I have subdivided my triangle face, and I have constructed one more triangle inside that. Suppose you assume, if you join these three vertices, what will happen? These midpoints, then you will get this triangle. This is one triangle. So initially, so now by calculating the midpoints, I have divided my triangle. So now you got one more triangle inside this triangle. So that is one iteration. So again, for this triangle also we have three different sides. For those also, if suppose if there is a next iteration, again it will be divided further. So again calculating the midpoint for those points also. So like this iteration will continues until my input. So whether it is 10 iteration, 5 iteration, like that. Like this is for only one phase I am telling. So same thing if you consider this phase. So mid 2, mid 4, mid 0 are the midpoints. If you consider this phase, again this. So like this we are going to divide your triangle. Then you are going to display the output on the screen. So based on the inputs, those many times it has to be divided. Okay, so this is the basic idea or logic. So we have to follow in order to subdivide your triangle or tetrahedron. Okay, so why we called as tetrahedron means because we are considering in a three-dimensional space, and we have considered four vertices, tetra. So four vertices A, B, C, D. Okay, so this is a simple diagram. Initial diagram I am showing here. This is not divided triangle. This is what initially we have predefined vertices values and identified the midpoints and constructed. So we didn't calculated any values here. Just we have show the initial tetrahedron diagram. That's it. So in the output I will show by giving the different inputs. We can observe the divisions. Okay, this is the initial constructions we have done for the inputs whatever we are specified in my program. Okay, this is tetrahedron construction and midpoint calculation, and the vertices values also given here. So V1 means vertex 1, that is A, similarly B, C, D. Okay, so this is the concept of tetrahedron. Now we'll go to the program. So same thing, they have given design, develop, implement, same question, again same thing repeating. So again we know already, so all the library functions we are going to include standard library functions along with the OpenGL library glut.h. Okay, and we have three different set of points we required. So just I'm going to specify those as a floating type. So point of 3, an array. So next initial tetrahedron I said, right, with the 4 vertices values I am going to construct my tetrahedron. So those point vertices I am going to consider here. So point V of, okay, so what are those values? So this is nothing but x, y, z value, because we are dealing with three-dimensional space. So that's why, so we have the 3 axis values for all the 4 vertices. xyz, xyz for one vertex for A, B, C, D. So whatever we have seen here, right? A, B, C, D. So these vertices values I am specifying in my program only directly. Okay. So next, so for some theta values also by default I am considering 0 because this is an equilateral triangle. So there is equal distribution of an angle for all the vertices. Like that, just I'm assuming as 0. So there is no any, I'm not specifying any angles over it. Just I'm going to make it as default 0 0.0, 0 0.0 for all the vertices. And I need one more input like n. So as I said, user has to given the inputs, right? How many times I have to divide my triangle. Okay, so that is what int n. So number of iterations, whatever it will ask when I am running this program, it will ask for n number, how many times you have to divide. So that is what the int n. So next, once that is finished, so declarations, the initial values, whatever we have considered, directly the control will go to the main function. Okay, here. The flow I'm telling how it will start. So initially I've done all those things. Now, so we have go to the main function void main int argc character star argv. So what is this? We already know, right? So argc. So what is this argc? It's an argument type of character. So what it will do? It will store whatever the string information we are passing through a command prompt. Okay, and this star argv is a like pointer argument. So it is going to nothing but a pointer vector array. Okay, so arg means argument vector array. So it's a what it will do? It will point to the whatever the values we have passed through the command prompt. So it will store that information whatever we are passing through the command prompt, and it will point, this argv is an array vector, it is going to pointing to those values. That is what this meaning of these two parameters. Okay, so after that we have to give the how many times we have to divide our triangle, that is printf number of divisions. So enter the number of divisions like 1 2 3 4 like that. So next, just reading those values, scanf %d %n. Next, glut init ampersand, whatever your value are taken. So just I'm going to initializing those values. What it will do basically, so we are going in order to connect, so your command prompt window to our OpenGL functions. Okay, so what this function is going to do, so we're going to connect the command prompt window so to my OpenGL functions, whatever I'm going to using in my OpenGL program. Just it is going to connect it. It is going to initialize in order to connect your command prompt window with the OpenGL functions. So that is what the job of this glut init ampersand argc comma argv. And we have one more glut init display mode. So in the previous program also we have, but we have restricted only to till this. So we have glut single and glut RGB. Nothing but we have a single frame buffer. In that I'm going to save my all the values in the RGB color values I am going to store. These are the two constant I am going to use in my previous program. But here one more parameter is constant is added, that is glut depth. So what is this glut depth? So glut depth is nothing but to initialize your depth information, because as I'm dealing with my object in a three-dimensional space, I have to calculate the depth information in order to show the invisible surfaces. So in order to show the invisible surfaces, I need to calculate the depth value. So that I need one more constant or parameter for my display mode function. So next, move on to that glut init window size. Again, as it is same, this is specifying the window size like width and height. So this is specifying width and height. What is the width and what is the height of my window? So next is glut create window. This is nothing but just to display the name here. When you are executing your program, here it is here somewhere in the left corner, it is going to show on the output screen. So 3D cascade, scanline algorithm, rotation of triangle, like that it is going to display. That is just display your program name on the output window. Next, we'll move on to the glut reshape function. So the glut reshape func of my reshape. So after that, your my reshape function is going to be executed. So what basically it will do? So in order to properly view my object, whatever I'm going to planning to display my ಈ ಕಡೆ ಇಡ್ರಿ ಫೋನು ಸಿಗ್ತಾ ಇಲ್ಲ. ದೀಪು ನೆಟ್ವರ್ಕ್ ಸಿಗ್ತಾ ಇಲ್ಲ, ಈ ಕಡೆ ಇಡ್ರಿ. Oh, sorry, I think there is network issue mostly. Just a second. Okay. Now I am audible?
Yes, sir.
Okay. Sorry for disturbance. Next is glut reshape func of my reshape. So that is what. So whatever I am planning or projecting my object in a viewport, okay. Whenever this function is going to be triggered, so when window is going to be reshaped, whenever the values of your width or height or whatever the vertices values you are going to pass, whenever it is going to changes, so the values according to that your object is going to be reshaped, and the same thing is going to be visible on the viewport, on the output screen or viewport or projection plane or computer screen, whatever it may be, on the display output devices. So that is what the reshape func. Okay, so along with the value changes, your object is going to be reshaped. So whenever those values changes, it is going to be triggered, and it is going to take the values, the whatever the changed values, and it has to be reshaped itself and projected on the viewport. Next, glut display func display. This is just normal display function whatever we are using. So in order to draw all the objects whatever we are processing in our program. Okay, so next we'll move on to this, because once this call the control will go to this function. So later we'll go next. Okay, so because once it is appear, it will go to the control to that function. Yeah, this is void my reshape int w comma int h. That is what. So whatever I am passing here in the main function window, I said right, window size, width and height, this is what w and h. So in here whatever input value I am passing here, so that value only it is taking in reshape. So that is int w int h in my reshape function. Okay, and GL viewport, you know, right? So where actually my object is going to be visualized on the screen, that is what your viewport. So there I am specifying values like 0, 0, W and H. So along with my other parameter, so I'm going to use my W and H also, width and height. Okay, so in order to project on the screen. So if it is changes, obviously the values also it is going to be changes. And matrix mode, you know already, GL matrix mode, GL projection. So what it will do? GL matrix function, matrix mode function. Any idea? GL matrix mode, GL projection. So what it will do? It will store the information, matrix information of the object what is going to be displayed in the viewport. Okay, it store, that is what the matrix mode, the word matrix. So whatever the object I am going to display on the viewport, so that object matrix values or information it is going to store. Okay, that is what matrix mode GL projection. Next, GL load identity. So this GL load identity is going to erase the previous matrix information. Okay, so it will not keep any of the previous iterations or any previous program information. If it is anything is stored or anything left out, it is going to erase that information. So okay, using GL load identity, it is reset to 0. Next, that is that if suppose width value is less than or equal to h, or anything, any cases, if any changes happened with respect to width or height of the object, so then we are going to use this function. Based on that, I'm going to calculate my new values. So either two cases, if suppose w is less than or equal to h, this one, otherwise it will go to the else part. So these values are like just GL ortho. So you just remember in my previous program we used to use GL ortho 2D, but here there is a missing of word 2D. So we are not using here 2D because this is a three-dimensional space. So that's why I'm going to use directly straight away GL ortho. If GL ortho you are using means it is going to identify we are executing in three-dimensional space. We should not write ortho 2D, sorry 3D. There is no any function like that. So for only two-dimensional they are specifying GLU ortho 2D, but in for three-dimensional space this is GL ortho. Okay, so these are the values like near, far. So I will show that in the syntax. So when we are discussing in the class, so whatever the near value, far value, height value, width, so all those values and along with your x and y axis values, we are going to pass. So this is what height, width. Okay, so x, y, z values, and we are going to use this formula in order to calculate your three-dimensional space. So where my object is going to be displayed, okay, in what area in the three-dimensional space, either two cases based on this W and H value. And GL matrix mode, GL model view. Once this calculations has been done, so how I am going to model view means how I am viewing my model, or how I am going to view my object after applying or after calculation. So based on the W and H values changes. Okay, so then the new values will be calculated. Obviously your projection plane, the area is also be changed from one place to other place. So all those, how we are going to, the new calculated values you are going to show store in terms of again matrix. Okay, those newly calculated values of the object after reshaping those values are nothing but matrix values also you are going to store in case of GL model view. So same thing, this is previously we have used projection, this is model. Okay, the after reshape done, so what is the matrix values of that object, that is going to be stored in matrix mode. Okay, so next glut post redisplay. So what it will do, it will keep the current window. So whatever the object will changes the values. So whenever we are going to perform this calculation my reshape function, so then all the it is going to marks the current window, so as need to be redisplayed, means whatever means post display before calculation. So before post displaying your object, so I'm going to calculated the is using the calculated new values I'm going to display. So just don't confuse with the other display function. This glut post redisplay is nothing but simple. So just I'm telling in simple words. So after calculating my all the values, new values, I am retaining my current window. Along with that, whatever the changes has been done, so whatever the model we have constructed with the new values, that I'm going, that model or object I'm going to display after this, means after doing all these things. That's it. So just I'm going to redisplay my object after performing my reshape function. That's it, simple. This is simple display function, but the why the name given like this means after performing all these changes we are going to display once again. So that is what the glut post redisplay. So by keeping the current window. Next, once that is done, again we'll come back to the main function. So this is done. So this is what the things we have considered with respect to the changes in width or height of the object. So next, glut display function mode display. So as usual, standard display function it is going to call. So we'll go back to display function. Yeah. So wide display wide, again here also we have two constants. We are using GL clear. In order to clear the buffer we are using this, and depth buffer we are using again same thing as this is a 3D case. We have to clear all the depth information also, nothing but the invisible surfaces information also we have to clear it. Next again same thing. So GL load entity to erase the previous matrix information of the object. Next we are going to call, once that is done, once we have cleared our buffer and all the matrix. Okay, so next we will call the tetrahedron function. So next the control will go to tetrahedron function here. So why tetrahedron int m. So here, we are anyhow we have already considered the vertices values. What is the v naught, v of 0, v of 1, v of 2, right? So here at the beginning only we have specified already here. So all the vertices values we already specified in my program only in the beginning only. So those values I am just using here. Okay, apply triangles subdivisions to the faces of the tetrahedron. So just this is in order to identify the color. So because if you give the same color for all the faces means you will not, your triangle or tetrahedron will be appearing in a single color. So in order to differentiate the different faces of the tetrahedron, I am using color 3f function. As I am using three values like x, y, z, that's why instead of 2f I am using 3f. Okay, so next, so this is you understood, right? Why I am using GL color in everywhere, just all the, for all the faces I am using this, because so I have to differentiate all the faces with some different color. Because of that I am using this GL color 3f. Okay, so next I am going to call my function divide triangle. So now the divide triangle, what it will do, so this is v of 0 means the vertex is 1, v of 1 is the another vertices, and v of 2 is the other third vertices. So using with these three vertices, I'm going to pass the one more argument parameter, that is m. M is nothing but midpoint. So as I said, so I have to consider three vertices along with the midpoint also I have to pass. Okay, so these are the inputs I'm going to pass in order to divide my triangle. Understood? So once this function called, so it will go to the divide triangle function. This one. So you have to follow the sequence. So whenever we have started with the libraries and we have entered into the main program, main function, there again we have jumped to some other, the how the control is going, I am moving according to that. Just you follow the same thing. Now why divide triangle? So here I need, as I said, the vertices, three vertices we required, right? So I'm just giving the name as A, B, C. Same thing I have given in the diagram also here. A, B, C, D, like this. Okay, same thing we are given. So these are the parameters along with the midpoint I am going to call. So now, so what are those vertices here? A, B, C, just nothing but we can say V1, V2, V3. Okay, we can call like that. So next int j, in order to perform the iterations, I need one more variable. That's why I'm initializing int j. And suppose now we'll calculate. If suppose the midpoint is greater than 0. If suppose midpoint is equal to 0, what will happen? So simple. If suppose if you are not calculating any midpoint, or if your midpoint is greater than 0, then what you are going to observe output? What output you are going to expect? Tell me. We have three vertices. We have constructed the triangle, and we are not dividing your, means we are not calculating any midpoint, nothing but obviously your midpoint will not be like greater than 0 or whatever it may be. That condition is not holds good, because there is no point of midpoint only, there is no concept of midpoint only. So if you run that program, what you are going to expect output, I'm asking. Shashank?
Yes, sir.
Program. So then what you, then your midpoint will be 0, right? In that case, because you are not calculated any midpoint, your midpoint will be 0. Here, just here greater than 0 is there. You don't take this condition. If m equals to 0, then what is your output?
I don't know, sir.
Any idea?
No, sir.
Simple. So there is no concept of midpoint means what I said. So directly it is going to construct whatever the diagram it is, an initial diagram, initial tetrahedron or initial triangle. That's it, right? Because we are not calculating any midpoint, but just I'm taking what I'm taking. I'm just taking the three vertices. That's it. So using that vertices, I'm going to project my object on the screen. If there is a concept of midpoint, so that's what, if this condition is true, then we are going to enter into the for loop. If the suppose if that's this condition is fail, if suppose the m value is not is the means not greater than equal greater than 0, then what will happen? This part. So are you able to see this line? Else part?
Yes, sir.
That is what. So just it is taking those ABC values, whatever the input values. So here there is no concept of m, because so the m value is 0. So just I'm taking only ABC value, means nothing but point or these 3 points vertices v1, v2, v3. Using that I'm going to construct my triangle. That's it. Just draw triangle at the end of recursion. If suppose this condition fails, or sorry, if condition fails, it is going to simply construct the triangle. If suppose this condition is true, if m value is greater than 0, means you are the user. When you given, it will ask for the number of divisions, right? If you give 0, what will happen? That is what the case I have discussed. If you give 0, there is no midpoint calculation. Directly it will construct whatever the ABC values we are passing to this function, it will construct. If suppose m value is 1, or m value is 2, or m value is 3, then what is that? Then suppose I will assume if m value is 2 is greater than 0. Yes, condition true. Then I will enter into the for loop. So 3 times I'm going to perform for loop. Why? Because I have 3 different phases in this. So that's why for j is equal to 0, j is less than 3, j plus plus. And these are the midpoint I'm going to calculate. So that is the first vertices I'm going to calculate. V1 of j equals to what I'm going to take? A and B. So look at here. Suppose if you are considering these A, B, then A of this one and B of this divided by 2. If you do, you will get midpoint 0. This is what? A of j plus B of j divided by 2. If you do, you will get this midpoint. Understood? This is the calculation, midpoint calculation for the first phase. Just I'm taking this phase. You assuming I'm calculating the midpoint for this triangle. So I like that I have 3 triangle, right? So for all the 3 triangle, I'm going to calculate the midpoint. And that's why I'm calling 3 times for loop. But here values are changing. You can see here v1 of j, v2, v3, and here also values are changing. And that's why again I'm calling 3 divide triangle function, because I have 3 triangles here. So if you consider this one, that's what a of j plus b of j divided by 2. If you do, that is what a plus b divided. So same thing I am applying. This is general formula. If you go to exact, this is a of j plus b of j divided by 2. You will get mid 0. So this is what the mid 0, the first. Like that for all the edges you have to calculate, for all the vertices combination you have to calculate the midpoint, so that you can able to get the new triangle. That is what the for one iteration, one time you are going to divide your triangle. Okay. So once that is done, so next I'm going to call recursively again this function, because see, look at this. For the first iteration, when I'm talking about if m is 2 is greater than 0, it will execute for the first time. Fine. So again I'm passing the new values, whatever the a value and v1, v2 along with the vertices values v1, v2, and I am passing m minus 1, because recursively I have to call for the second iteration, right? That's why now what is the m value? 2 minus 1. So now what is the input for the next iteration? Your m is 1. Again it will come here. So again checking if 1 is greater than 0. Yes, condition true. Again it will come here. It will check. It will find out all the midpoints, and again it will come to the again second time. So divide triangle. If m is 1 now. 1 minus 1, 0. So again, it will come to the condition checking. If m is greater than 0, no, condition fail. So it will come out of the loop and it will construct the triangle with the new ABC values. Here, see A, B, C. These are the new calculated values. So using those values, you are going to construct the triangle. So any doubt in this logic, because the main logic is in this function only. So please let me know. Anyone not understand this divide triangle function? Because complete logic is here only. So all other supporting functions. Fine. Shall I move to the next? Shall I move to the next?
Yes, sir.
Yes, sir.
Okay. Fine. Okay. So I hope you understand why we are using again. Sir, already we are using divide triangle here. Why you are using again? Anyone should get doubt this. So as I said, so as the iteration, your value is different, it's greater than zeros, you have to perform recursively. You have to perform recursive subdivisions. That's why I am taking the new values, whatever we have calculated here, along with those values, I am passing once again. So with the new midpoint value, so that so that you can able to calculate, right? So initially one triangle is there, inside that one more triangle came, again for the next iteration, again inside that one more triangle, like that it will keep on recursively calling. That's why we are using again divide triangle within the divide triangle function only. So that's it. That is one thing you should remember. That's why we are using one value, we are going to decreasing for the next iteration. So m minus 1. So if suppose m is equal to 5, you have some around 3 to 4 iterations, you will get it here. Okay, so I have taken m is equal to 2. That's why it is finished in 2 steps only, 2 iteration only. So it will come back. Once that is completed, your divide triangle function will go back to here. Yes, here. So here we have done. So far we have done only for this vertex. So this face. You understand? So whenever I tetrahedron function called, and we have considered the first divide triangle function for one face of your tetrahedron. So till whatever I did, that is only for one face. So here, so you have anything here, suppose you just have done for only this one face. Like this, you have to call for all other different faces. That's why again, so the other face will be identified with this color, and this is the input value. And similarly for the other face, again another color. So again I'm going to call like this. I'm going to call all the 4 different faces, because you can able to see only 3 faces here, but at the bottom you have one more face. If you are observing, so there is just here 1, 2, 3 faces are there, but just when you're looking from the bottom, so you can able to identify the base also. That is what this ABC. So ABC also one face. ACD, this is one face. ADB, that is another face, and similarly BCD, this is another face. Okay, you can able to see 3 faces, but at the bottom base, the triangle base, that is also one of the face. That will be the 4th face. So like that, I'm going to divide my triangle for all the faces, and I am going to specify with a different color. Otherwise, if you give the same color, the full complete triangle will be appear in only one color. So there we cannot observe the division. So once that is done, here where we are. So when tetrahedron called, we have done all these things. Okay. So again GL flush. So our job is over. We have identified, or we have subdivided all our triangles, and this using GL flush, what we are going to do. So whatever the objects we have processed in our divide triangle function, or in OpenGL in this program, wherever, so all the object it is going to draw. Okay, it will draw all the possible objects. So using this function. So next the control will come here. So this is over now. So in this only we have again sub functions we have worked out. So and the last is GL enable GL depth test. So this is whatever I have showed here also. In the beginning I told, right, here we have, in order to enable depth, something like that I said right here. So glut depth. So same thing only. So what it will do, if you're using this function, if you're using this GL enable, name itself telling enable. So what it is going to enable? GL depth test, enable the depth information in order to view the hidden surfaces of the object. So that is what your GL enable, GL depth test. It is going to test that. Okay, so next clear color, just it is going to clear the screen, and glut main lobe. So all this process will be running, so one after the other. So that will be done by the help of a glut main lobe function. Okay, so this is how the process or the program is going to work. So you have to identify, you have to this is the flow. Any program you can observe, you should go through the flow. You should not start from the beginning. So when you start reading the program, you should not so just go like this. Just for the practice, we have to write like this only. But in order to understand, you have to go through the flow only. Then where the function, where the control will go. Next, which function is going to work. Then where the control will come back. So like that you have to follow. Then then only it will be easy. Otherwise, there is no meaning. Why triangle is here? And that's what here one thing I forget to tell, sorry, just see. So I didn't explain this one. So then triangle I said, right? So after calculating all the new values, so or any default values, this function is going to call. So this is what the beginning function. So here triangle, simple. So what, how we are going to use the construct the triangle using that GL begin. So GL polygon and all the vertex, 3 vertices we are passing A, B, C and GL end. And you can observe one more function I have included here, GL. This is optional. If you want, you can write it. Otherwise, you can remove this also. So what this will do, GL normal 3FV function. Suppose if you are considered, because we said, right, for each vertex we are assigning one color. So in that particular vertex, we are equally distributing the intensity of the color. The intensity equally distribution will be taken place if you are going to use this function. That is what, just equal distribution of intensity at a particular vertex. So if you want that one, you can use, you can go for this. It is optional. If you want, you can use. Otherwise, you can remove and you can specify only these 3 vertices. So this is how the triangle is going to be constructed. Okay, that this function is calling inside your divide triangle function. So that's end of the flow. Okay, so you should not simply go starting from here. You should not study white triangle. First, you will not construct any triangle. So there is no meaning only. We will not directly divide the triangle. So okay, function is like this, but the flow is like this, how I explained. So how it will start from the main function, how line by line the control will go, and how the inputs it will take, and how it is going to divide and draw the object. Finally, what we are going to see on the output screen. Okay, so this is complete the flow of Sierpinski gasket tetrahedron program. Okay, so if you have any doubt, please ask me. So meanwhile, I will go for the execution and I will show you just later. If any queries, if any questions, so I will answer. So this is the program. So I have created the program number 7 like that. In source file, I have added a new. So just like this, I have to add. So if for any new program, add new item, then sample window it will come. Then there I just type my program and saved it as Sierpinski gasket like that. Okay. So you know already how to this. Just after saving, just to click save, then go to build solution. So here it will come if any error is there or any success, something like that. Okay, because I already multiple time executed. So next execution. So are you able to see the screen? So are you able to see this pop-up window?
Yes, sir.
Okay, so just I will go back to my program. See what it is asking, number of divisions. So I have to specify number of divisions. How many times my tetrahedron or triangle is going to be divided. So let's start with the 0 only, because we have discussed 2 cases. One is 0 and another case is greater than 0. But 0 means else part is going to execute it, as I already told in this divide triangle. divide triangle. So if m is equal to 0, I will not give in the first case m equals to 1 2 3 like that. First I will check for the else case, m equal to 0. Suppose this condition fails, by directly taking this ABC value, it is going to construct the triangle using this triangle function. Okay, that condition I will show you. So I will give 0. So are you able to see the output? Hello? Hello?
Yes, sir, we can see.
Yeah, this is for 0th case. So here you can able to see 3 different phases. I didn't calculated any midpoint here. Okay, so just normal triangle tetrahedron I constructed. Now you can observe this is one face, black color, blue color and green color. But at the bottom, just by considering this point and this one, so at the bottom we have another face. Okay, so this is for the case m equals to 0, else part. So it is going to construct it a simple triangle by taking the initial input value. Now I will check for the remaining cases. You can give any cases m is not equal to 0. So now I will give m equals to 1. Yeah. So this is how the midpoints have been calculated here. So in 3-dimensional perspective, you have to think. Okay, so that then you will understand. So this is what the one triangle. So it will be like this. This is the top point, and these are the base. This is what the base. Similarly like this. So these are the midpoints we have calculated here. See, and here also, here also, here also. Like this we have calculated the midpoints, and using my reshape function. So again these new calculated values are again passing through the divide triangle function, and once that is all the iteration done, so it is taking the new values, and it is going to construct the new triangle. This is for m equals to 1. For all the faces, it is going to divide your triangle one time. Now you remember this is the output. Previous case you remember, right? You just remember the output, so that you can see the difference for the other input. Now I will give m equals to 2. Now you can expect more number of triangles in this for this case. So are you able to identifying any difference between the previous 3 outputs when m equals to 0, m equals to 1, m equals to 2? So is there anybody in the call?
Yes, sir.
So are you people seeing any difference in these 3 output when m equals to 0, when m equals to 1, and when m equals to 2? What is the difference you are observing?
Base is changing, sir.
Okay. So next I will again I'll give the other input. M equals to now 3. Fine. I'm going to give m equals to 4. So like this you have to divide your triangle. So if suppose values are more at particular some time, your triangle itself invisible, because it is beyond your screen limit. You will not identify any this one. Just I will go with some higher values. Let's see for 15. You are not able to see your triangle itself. Okay, means that much small pixels it has been. See, the single triangle will be appear as a single pixel. Okay, so if the values are increasing, those many times your a smaller triangle is dividing, so it's keep on recursively. You cannot able, even single pixel will also be act as a triangle. Okay, that's why for usually for the higher values it's very difficult to see the output. You cannot see on your screen, but it will be there, but very a small pixel you cannot identify on the screen. It will act as even single pixel. It looks like a dot, but that is not dot, that will be a triangle. Okay, so that is how you are going to how the your Sierpinski gasket program is going to work. Finally, just have for the 2-3 cases I have just taken output. I have put here for division 1. It looks like this. So for division 0, just I can we can, there is no division, just simple diagram, simple tetrahedron we have drawn. And this is for division 5. We have got the output like this. Like this, you can give the different inputs and you can divide your triangle. So that's it from my end. So if any have doubts, if anyone having any doubt in any function, please ask me. I will just try to answer your questions.